for experiment 5, determination of equilibrium constant part 2, the calculation that you're first asked to do is calculating the mass of water in HCl, and that is under the assumption that the density of 3 molar HCl is 1.05 grams per milliliter. So the way to get to the mass of HCl, the water in HCl, is to find the mass first of 5 mils of 3 molar HCl, and that's the 5 mils that you added to your mixture on part 1. So this is the 5 mils of HCl that you added on that first day. Okay, so if you have, to figure out grams of HCl in solution, you have density, this is the grams of the solution. So the grams of the HCl solution. You have density in grams per mil times volume in milliliters. So these will cancel out, mils will cancel out, you're left with grams. So 1.05 grams per mil is the density times the 5 mils that you added. So your grams of HCl solution should be 5.25 grams, and that is the mass of the solution. To find the mass of HCl itself in solution, you're going to use the mass of the HCl solution here times the volume of HCl that you used times the molarity of HCl, and then times the molar mass of HCl. So this molarity should have been calculated in the last video, so you can go back to that video to see what your HCl molarity was, and then the molar mass of HCl. So this is in liters, this is in moles per liter, and this is in grams per mil. So for my values, this is the 5 mils. I know it's hard to see there. So this is 0.00500 liters times my molarity of HCl. My fake molarity is 3.402 moles per liter times the molar mass, which is 36.46 grams per mole of HCl. So these units cancel out and I'm left with grams. So this ends up being 0.620 grams. Okay, so that is the mass of HCl in solution. Then you have to find the mass of water in the 5 mils of 3 molar HCl. So HCl has been diluted with water, so we want to find the mass of water in that. So the mass of water in solution equals the total mass minus the mass of HCl. So 5.25 grams, which is the amount you found here, that's the solution mass. You're going to subtract the HCl mass, which you found right here, and that gives you 4.63 grams of H2O in HCl. Okay, then we got to find the moles of water in 5 mils of 3 molar HCl. So we're just going to convert this. So moles of water equals the mass of water divided by the molar mass. So 4.63 grams of water times 1 mole over 18. That's 0.257 moles of water. So this is for trial A. It's also true for B and C because you added 5 mils of HCl to all of the trials. Okay, so next I have to calculate the mass of water for trial B. So you're going to add the mass, so that last one was the mass of water, or moles of water for trial A. And the place that you would put that is here. So this is for trial A. Your ethanol and your acetic acid is 0 and 0. So again, this is in your lab manual on page 47. Your moles of water beginning is 0.257 that you just calculated, moles. And then we can calculate for B. So the way that you would do B differently, that one has an extra mil of water. So you're going to add the mass for 1 mil of H2O. So the mass of water, again, density times volume. Density of water is, you can use 1.00 grams per mil times 1 mil of water. That's 1 gram of water. So this you're going to add to the value of the mass that you just found. So that 0.257, or the total mass. So this is 1.0 grams of water plus 4.63 grams of water. I'm just going to go back a page so you can see what I'm talking about here. So that's this mass right here of water. You're going to add the 1 gram to that and then convert it to moles of water. 5.63 grams divided by the 18 equals 0.313 moles of water. So for trial C, you would add 2 grams to that and then convert that to moles. Okay, so far my lab report looks like I had the 0.257. For moles of water in trial B, it's 0.313 moles. Again, this is 0, 0. So we'll come back to this page again briefly. Okay, so after you found the moles of water, we need to calculate the moles of ethyl acetate initially. So we're given that the density of ethyl acetate is 0.893 grams per mil. For vial B, the mass of ethyl acetate equals density times volume. So here's the density times the volume. 4 mils of ethyl acetate was added to B, and that ends up being 3.572 grams when you calculate that out. And then you have to figure out the moles of ethyl acetate from that. So that's just the mass times the molar mass. 3.572 grams divided by 88. So you get 0.0406 moles. So again, this is how you find the initial moles of ethyl acetate. So that's another value I can add to my table, 0.0406, actually it'll be the same up here, and for part C. So again, determine for A and C, they should all be the same because well actually they're not all the same. This is incorrect. So you added different amounts of ethyl acetate. This hopefully is larger, and then the C is smaller. I'm sorry, the HCl was the one you added 5 mils to each of them. Your next task was to determine the moles of acetic acid in each sample. So again, I'm just going to do it for trial B. So let's say my volume to the endpoint was 38.26 mils. My molarity that I found from last week, again, you can go back to that to figure out how to find the molarity of sodium hydroxide, is 1.055 moles per liter. So the moles of NaOH equals the moles of acid. Not necessarily of acetic acid. So you want to count or factor that in because we added HCl as well. There could be extra HCl around. So this is going to tell you how much acid is present. So the volume of, the moles of NaOH equals the volume of sodium hydroxide times the concentration, which we've been doing. So 0.03826, and that comes from up here, so whatever your total volumes were, times 1.055 moles per liter. That equals 0.03467 moles. And that's the number of moles of acid that was titrated, not just the moles of acetic acid. This is the HCl left over plus the acetic acid. So we have to subtract the moles of HCl from the total moles of acid. And we can do that, finding that by the volume of HCl in liters times the concentration. So that was 0.00500, so that's the initial 5 mils of hydrochloric acid, times the molarity of my HCl was 3.402, so that ends up being 0.01701 moles of HCl. And then to find acetic acid, we have total moles of acid, which is up here, minus the moles of HCl, so 0.03467 moles minus this moles equals 0.01766 moles of acetic acid. Alright, so we can go back to here now. Okay, so your 0.1766 moles goes here. 766. And that is a 1-to-1 ratio with this, so this becomes 0.01766. And then you can just complete the rest of your tables and do the equilibrium constant as well based on the initial formulas. So you would just complete your rice table. These are incorrect here. So this would be your values there. And then just do your K equilibrium products over reactants. And for K equilibrium for me is 0.0463. So you can put that value in here, and that was for trial B.